Hello, everyone. Welcome to the very first seminar of the Health Terminology and Interoperability Standards, or HTIS, seminar series. My name is Linda Bird, and I'm an adjunct assistant professor here at the University of Victoria and also the instructor for HIMP 597, which is the field project in health informatics, and we are hosting this seminar series. Before we get started, let's begin with our territory acknowledgement. We would like to acknowledge and respect the Lekwangans, Songhees, and Coseps and Esquimalt peoples on whose territory the university stands, and the Lekwangan and Wasanich peoples whose historical relationships with the land continue to this day. So, as I said, today is the first seminar in our HTIS seminar series, and we're very lucky to have Dr. Alejandro Lopez, who's a good friend of mine from SNOMED International, to join us and tell us all about SNOMED CT trends and latest developments. But before we get to that, let's take a quick look at the next few weeks. So next week, I will be presenting a follow-up seminar on SNOMED CT as the foundation of computable clinical meaning. And then on June 25th, Laurie Block from Vancouver Coastal Health will join us to present on nursing data standards in Canada. And then the fourth seminar will be on HL7 structured data capture with Dr. David Hay from New Zealand. Then on July 9th, we have Debbie Pinter, Debbie Onus, and Laurelie Lawson joining us to present on building a better health record at Alberta Health Services. And then finally, we'll have a short break while the students focus on their environment scans, followed by Dan Simic and his team from the Health Information Standards Group at Connected Services in British Columbia. And they'll be joining us to present on their work. So there's a lot to look forward to over the coming months. Also, please note that these sessions will be recorded and shared on the school's website. And so now I am delighted to introduce to you my friend, Dr. Alejandro Lopez from SNOMED International. Alejandro is a family physician and medical informatics specialist trained at Hospital Italiano of Buenos Aires, Argentina. For the last 20 years, he has collaborated with different digital health projects worldwide, contributed to international working groups on standards and interoperability, and consulted on implementing national digital health agendas. As National Director for eHealth in 2019, he was in charge of designing and implementing the National Digital Health Strategy at the National Ministry of Health in Argentina. He was World Health Organization Digital Health Technical Advisory Group member from 2019 to 2021, and he is now a Senior Implementation Specialist at SNOMED International. So with that, I will pass the screen over to Alejandro for his presentation. Thank you so much, Alejandro. Really appreciate you joining us.
Thank you, Linda. Thank you for the invitation. And thanks for the flexibility because we had to switch dates. So it's really good. So in general, every year, we want to bring you with the latest things about SNOMED. The details you will learn from Linda. Linda will go to this particular details of SNOMED CT, and we work together for a long time. So we know we say the same things in parallel. So I'm trying to avoid saying what Linda will say next week. So we will focus today more in what's happening in SNOMED, what are the new things that are appearing. And to give context to the trends and to the novelties in the SNOMED CT, I created this infography with AI, of course. You know, these things were very difficult before, but now are simpler, right? So what we try to do in SNOMED International is try to, in this implementation support team that Linda created a few years ago, it's a team that specializes in supporting the whole cycle of the adoption of SNOMED CT, which is a complex cycle which has many steps. Yes, SNOMED is published monthly in the international edition. Yes, and it's translated and adapted by many countries to Spanish, to French, to German. And also there are collaborations with other organizations that improve SNOMED. They create additional content that specializes SNOMED for a particular purpose, or they review the content of SNOMED so it's fit for purpose for particular use cases, or they create maps. So these clinical groups, these SDOs, standard development organizations, work in collaboration with SNOMED to improve continuously SNOMED CT. So the implementers that want to apply SNOMED in a real world scenario are faced with a collection of things that they need to implement. They have an international release, an extension from a country, a mapping from Loing. So they have different resources that they need to put together and try to somehow bring to reality. And this is done through terminology servers. The terminology servers are software applications that support the idea of bringing a lot of terminology resources together, and they present that to EHRs, to clinical software, electronic health records. These electronic health records use the terminology servers to access the terminology. And these are the tools when the terminology becomes a reality for clinicians. The clinicians now, when they enter a diagnosis or when they order a procedure or when they're prescribing a medication, instead of writing free text, they are selecting concepts from a terminology. And this is querying a terminology server. And of course, every day we have news and we have new initiatives that try to facilitate this process, to say, okay, today the doctors need to type and search and they find things, and that works really well. It requires some training, but now there's been new processes are being evaluated, like the audio scribes, like systems that will listen to the conversation in the doctor's office, and they will, in real time, will start to create a summary of the clinical consultation, and it will attempt to automatically select codes, something that the doctor will then validate in some way. Yes. And then when we have all these wealth of information that everything is coded, either manually by the doctors or with an automatic step with some revisions, we have tons of clinical records of patients or millions of clinical records of patients that have codes for diseases, codes for procedures, codes for medications. You can start taking advantage of that. And the way to take advantage of that information is through clinical decision support. So how I can improve quality, how can I improve the how I can prevent errors, or can ensure that clinical guidelines are enforced and applied properly. So these decision support tools are things that, based on the coded information of the patient, provide alerts to the doctor. They say, be careful, we need to control this, or this is important. And the new buzzword for this is this whisper. Yeah, so the systems will listen, will scribe and code, and they will whisper back to you in some discreet way, maybe with some text in the screen, and it will give you information about what's happening. Yes, and it will allow you to steer the conversation to some places, or to give you a reminder to the patient, or to discover that the hospital has a clinical guideline that applies to this patient, or maybe has a clinical trial that is related to the medication this patient is taking. This patient is a good candidate and can apply to the clinical trial. So these systems are feeding information back to the doctor. And the analytics part is the part in which you process tons of information, you create reports, you do actual clinical research with real-world data, you measure the impact of clinical policies or public policies in healthcare. You have dashboards that will report everyday trends, and you can change processes based on the trends that you see, or you can just explore data in an intelligent or meaningful way. So this is what SNOMED provides, from the publication to the best benefits you can get with SNOMED CT, right? So the trends that I will show you apply to some of these steps. Yes, we will see some tooling, we will see some demos, we will see some guides, and all these new developments this year in SNOMED CT try to simplify this in some way. So when I describe different initiatives, we should remember this process, and this is what we're trying to streamline. We try to make it simple, that every month a new diagnosis is published by SNOMED CT, and that as soon as possible that diagnosis is available to the doctor in his native language, to be coded by himself or by AI, and to be able to be used for analytics and reports. Yeah, so this is the complex process that we need to go through. So we will see some tools. We will see the use of AI in the SNOMED. We'll see some demonstrators and some updates on the implementation guides. Yes. So let's start with the tools. Yes. And the first tool that we show every year, but this is growing and it's good to. Linda was one of the pioneers thinking about how these tools can take shape in the SNOMED community. And this is something that allows you to create your own extension. And this is working on the first part of that diagram. Yes, SNOMED publishes the SNOMED release, and then it's adapted by a country, either translating or mapping or doing subsets. And this tool is more mature every year. There are more countries using it, and the countries are releasing national editions created using this tool, and they use this tool to add local translations, to add local concepts, very simple local concepts to represent perhaps diseases that are very local, endemic to those countries, or maybe new medications or new procedures or different types of food that can be allergens or substances that are only present in that country. So the Simplex Toolkit is a tool that is available for those who want to do a customization of SNOMED-CT. Yes, they want to use the international edition, or maybe even use the national edition or the Canadian edition. And they want to add another layer of customization. They want to say, okay, I will want to add this content. So when SNOMED goes through the cycle, it gets presented to the clinician in an electronic health record, SNOMED will contain these local condiments, will contain these local concepts, these descriptions, these maps, and things like that. So this is a very interesting tool. Maybe we will do demos of some of them, maybe the ones that are more interesting, but it's good for you to know that in the beginning of the process, you can customize the content. And one of the great efforts of SNOMED-CT is translation. SNOMED is not automatically translated to all languages. Each country is translated by themselves. And maybe if several countries use the same language, like France and Canada, they establish some kind of collaboration, or like Germany and Sweden and Switzerland and Austria, they work to translate into German. So translation tooling is really important for SNOMED-CT. And Simplex is the main tool that we use to package those translations and send them to a terminology server. But before packaging, we actually need to do the translation. And to do the translation, we had a tool that was called SNOMED Weblate, which is a very interesting internationalization tool used for software, for many things. It has many adaptations. But maybe something to tell you is that we are working on a successor to Weblate. Yes, Weblate has some limitations with the technology, in the way it can grow, how many concurrent users you can have, how large can be your translation. There were some challenges into trying to push Weblate to be the main translation tool of SNOMED-CT. So we are working now on creating a translation studio tool. We call it internally SNOWLATE. But this is aimed to be presented in the Expo in Porto in the coming months. But the goal is to have a more dynamic, a more flexible, a tool that is more simpler in a way that doesn't require so much memory. It supports more users using it concurrently. It supports making big changes in a very short period of time. And of course, that is natively integrated with AI processes. Yes, this tool, Weblate, allows you to translate using AI, each one of the terms one by one. You need to click translate, translate, translate. But the new tool, the Translation Studio, is thinking about applying AI to translate large sections of the terminology. So the message in this trend that I want to share with you is that know that the possibility of creating translations in SNOMED is evolving. There will be new tooling by the end of the year. There are new initiatives. These AI-assisted translation tools are being tested. We will say a bit more about this later. But yes, so it will be simpler. So now it's simpler to have your own adaptations with Simplex, and it will be simpler to translate to different languages using the tool that we are preparing to release later. And the next stage of that is, after translation, there are some things that are common use cases. Yes, probably the most common things that you implement when you're applying SNOMED-CT into a real-world use case is creating maps or value sets. Yes, maybe you didn't see the presentation from Linda yet, but of course, a map is a link between a SNOMED and a different terminology. And usually one of the most common maps that you use is to say, okay, I have this terminology in my system, maybe this procedures terminology that has 1,000 procedures that doctors use to order things in the hospital. And I want to keep using these, and I want to assign SNOMED code. So in this way, I don't need to change my system because the terminology is perfectly usable for me. And I know SNOMED has many other procedures, but these are the ones that are really relevant for this use case. It's not like I can order a procedure that is not performed in my hospital. So I'm comfortable staying with this. This is usually not the case for diagnosis. In diagnosis, usually you want to have as much coverage as possible and more freedom. But for some cases like medications, procedures, and some forms and things like that, you can keep using all local terminologies, but when you map them to SNOMED CT, you're unlocking more power. Yes, you're recording something that has your local code, but also has a code that can be interpreted by other people. That is part of SNOMED, which is a large ontology. Each concept in the SNOMED ontology is related to other concepts in a hierarchy and it has attributes. So having a SNOMED code for each one of your local concepts is really a great value for interoperability, for connecting to knowledge bases and things like that. So we have a tool that supports doing that, and there were more and more improvements on that tool in order to being able to export FHIR resources for that. And the other use case for small customizations is to create value sets, to say, okay, SNOMED is very large, but they will create a small value set for a particular purpose. A value set with the diagnosis relevant to this office, or a value set with the options in this question, and things like that. So these value sets are really a way that implementers have of customizing how the system looks for a clinician. Well, they don't see the whole SNOMED CT terminology, but sometimes in a structured form, they click on a button and they see 5 options, and these are the relevant options to choose from. So the creation of value set and the creation of maps is really a way to customize SNOMED CT. And because we are growing in the use of HL7 FHIR, when we say terminology server, we talk about FHIR. It's more and more common that you use SNOMED CT releases as they are without creating an extension sometimes. But when you want to customize how the terminology is used, you insert FHIR resources. You insert a FHIR concept map, you insert a FHIR value set. And this I can show you a bit to show you how this looks in reality, yes? So we will do this. We will try different utilities. And so you have an idea of what kind of things you can do with SNOMED CT free tooling. Yes, this is available to all SNOMED licenses. And SNOMED is free of access in member countries. Canada is a member country. And you can, of course, access these tools for free to work on that. And this is Snap to SNOMED. I think that's also really familiar with this. Snap to SNOMED is a tool that is prepared to map local terminologies to SNOMED CT. So let's use this project. This project is a project that contains like a local terminology with a few diagnoses written in local terms, yes, and using this tool, you can find maps for each one of them. You can do automatic matching, but also you can go here, for example, you can say swollen ankle. You can say, no, this is normal. Let's fix this and find a right ankle edema. Maybe ankle edema is a good finding for this. So I get swollen ankle and I put it in equivalent. Yes, and then I click, this is mapped, and I go back to the list, view map. So now I have a relationship between my local code, T10, and a SNOMED CT code called ankle edema. So if in my system, I'm recording T10, if I'm my clinical database, I have a patient that has a value assigned of T10, now I know that T10 is actually ankle edema. And if I want to look ankle edema in the SNOMED browser, let's look at it in the Canadian edition, for example. I'm loading the free SNOMED browser, Canada, and I look for that concept ID, ankle edema. Having that code there opens the door for having the ability of exploring the information in many rich ways. So, for example, an ankle edema is a kind of edema in the lower extremity. So you can find all the edemas in the lower extremity mixed together if I want to search using this node. And also it's a kind of finding in the ankle region. So if I want to find ankle problems, I find the edema, the sprain, the fracture. Everything is stored at the finding of the ankle region. And if you go up in the hierarchy, you start to see the parents and the parents and the parents. And this is the SNOMED hierarchy that contains this information. Yes, finding of the limb structure, and you have all the multiple aggregation, yes, of SNOMED CT. You can find all the edemas in all parts of the body are below this node that says edema. This is the SNOMED ontology. And each concept is aggregated into this ontology based on its attributes. So this concept ankle edema is based on having an attribute called finding site in the ankle region structure, and edema, an attribute of associated morphology with the value of edema. If I go to ankle structure, it's also a concept in SNOMED CT, and this is the general neighborhood of what's in the ankle, yes, and what are the structures more general than the ankle, and the more specific ones below. So when we show this kind of mappings, what we are doing is T10 has no meaning before. T10 was a short list in the system. Yes, it has no special information behind T10. But when you match it to a SNOMED code, you have all that information available. And then you can select, give me all the T's that are related to the ankle. And you can do that with a query. And this is how and why we do all this. But what we worked more into normalizing. This was here before, but it requires some adjustments into exporting this thing. So I can export this map, and I just exported this JSON file here. And this file that I exported is not just a table, it's a file resource. It's something that I can put in a terminology server. And we will show you how to use that later. So this free tool allows you to map your terminologies to SNOMED and store that information in a way that can be shared in a terminology server. And this other tool that we have, let me grab the ECL, is the other one, is the value set utility, yes? And this value set utility, let me share I will show the link in a second in the chat. The value set utility allows you to exchange formats and to create fire value sets from information that is stored in different ways. So you can upload a CSV, you can upload an Excel, a TSV, a JSON file, already a value set. It's really flexible in that way. Or you can enter an ECL expression. And an ECL expression is a way to do a query of SNOMED CT content. Yes, and let's do that. If I click on Query Builder, yes, I can say, give me the descendants or self of asthma, for example. Oh, sorry, I hide. Yeah. Oh no, because this is not. I need to switch to a different one. Let me switch to international derivatives. This one, because I want to show you something with the IPS. The descendants or self of asthma, and then you can add a second clause to this query and say, or no, let's do an and concept, and it's a member of the international patient summary. The international patient summary is a ref set, is a value set that contains the more relevant concepts for the international patient summary creation. So it's a smaller set of SNOMED CT based on frequency of use. So if I click here and I do expand ECL, I found 14 concepts. And these 14 concepts are 14 SNOMED CT concepts that are related to asthma. Yes, let me share this with you, the link in the chat. So if you want to explore that later. And now that I have this list, I want to extract it and being able to use it as a fire resource. Yes. And to do that, I will do generate fire value set. and I will say here, I will add a URI. This is the way value sets are identified or file resources are identified. So I say it's 100.org/value sets slash asthma. For example, this is my asthma IPS value set. Let's do that. And I say asthma IPS. Yes, and I say this is version 1. And I generate the value set. And then I click download and I have a file. I don't know if you see the pop-up, but I have stored now a concept map and a value set. So I'm using public tools to create maps or subsets related to particular use cases. And in the next section, we will see what we do with those files. Yes. So this is a way in which you can customize this kind of because you can customize the terminology to the particular use case that you're looking at. And this is related to the next step. So now you should be able to import this value set into a terminology server. And to do that, we have like also advances in simplifying the adoption of terminology server. Remember the cycle. We are advancing in the cycle. Yes, before we talked about generating the release, generating translations, generating a national release, generating file value sets or maps. And now we are talking about deploying them to the terminology server so a clinician can use it. So we are in the part of deploying to a terminology server. This usually used to be a really complex thing, but as time goes by, we're trying to simplify and simplify and simplify. SNOMED has this family of terminology servers that is the Snowstorm family, yes? Snowstorm is the classic and the most powerful terminology server, and Snowstorm Lite is like a simplified version that works with less memory, it's faster, it's easier to use, and maybe it's the main thing that you should do in this if you're trying what is a terminology server. And the novelty this year is that SNOMED has developed a dashboard for the terminology servers. So when you install a terminology server, now you have a tool, you have a screen that you can play around and you can work with that. Yeah. So let me show you, these are the GitHub repositories. This is open source, all the source code is here. You can download the code, you can do everything, you can branch it and make your own changes, you can do whatever you need. But the process of deploying this server has been streamlined a lot. So we have a quick start here. Yes, and the quick starts involve using Docker. And Docker is a tool. I don't know if you are familiar with Docker. Let me show you. I have Docker running here. I go to the Docker dashboard. Docker is a tool that you install in your computer, and it's a host for containers, for virtual machines. Yes, and these containers are software that you can run completely independent of the rest of your system, and will contain all the dependencies there. And the beauty about containers is that we can use it for testing really quickly, but also if you want to go to production, you use containers as well. So it's like a technology that is very scalable in that way, and you can coordinate different containers and things like that. So if we go back to the presentation, let me see here. These are the instructions about how to use terminology server. So usually when we try to explain someone how to use a terminology server, we used to have like a developer day, we called it, and we spent like 8 hours with software developers to show them how to use a terminology server. And this is something that is so quickly that I can show it to you now if you want. And that's that's what I will try to do now. So let me open a terminal. With terminal is like a file, new tab there, and I will close the other tab. There, I have a clean terminal to share with you. So what I did was to open this in my Mac machine. Yes, this computer, it has Docker installed. That's the only thing it has. And if I do cd documents, and then if you're not software developer, this will look strange, but just want to show how quick it is. And then I do snowstorm. So the only thing I have here is a file that contains my passwords for the syndication system. That is really interesting. Simply is the way we can exchange, or we can access to the latest version of terminology. So if I do this Docker pull, this automatically makes the computer to go and retrieve the latest version of SNOMED from GitHub, from everything where it's deployed. Yeah, so this is takes, or that's ready. We have the image of SNOMED or already now in my computer. And then to execute SNOMED is this sentence that I paste from the web page. I'm copying and pasting from the web page. Yes, and you click that, and it's running. Yes, and this is something that took a lot of time before, and now we're doing it in a second, and we will use the command line tool now. And if I go now to localhost 8080, I'm welcomed by this. Yes, and this is the dashboard, and this is the revolutionary thing. If you are a data scientist, if you are an implementer or you're a developer, having your own terminology server that you can deploy for free and you can keep updated and you can do all the queries you want is extremely valuable. Yes, because SNOMED is so large and it has so many features that accessing SNOMED using the database is really, or the text files using the release, is not really a good way to access SNOMED. You need to use a Fire API. So this dashboard uses a syndication system. A syndication system is a way that SNOMED has designed to provide access to all the versions of the terminology going around. I have the credentials to access the syndication system, and those are stored in that file that I showed you. Those are secret. And then I can choose which edition I want to click. And you select the edition. For example, I will not do it because I will show you in a different instance. You click select, and then okay, you're going to use the Argentinian edition. Or let's use the international one, something like that. And you say, okay, I will add the dentist. These are the collaborations that I said. I will add the dentistry package. Yeah, I will add the dentistry package. I'm not interested in the GPS, but I want the NCPT one, the nutrition care process one. And you select that. And then when you click install, it will automatically download and install everything, and it will be ready in like 2 minutes. Yes, because it's really that easy. It's really, really that easy. But what I will do now is I will switch to a local server because I will show you the future of the dashboard that contains even more things that you can do, and it's related to how you use those files that we created, the map and the value set. So I stop this server, so this server is no longer running there, good. And then I will run a local server I have, which is the development version. Yes, so I will do this. Oh, give me a second. I need to export. Okay, oh, this one here. Sorry, I'm in the other screen, and I'm trying to. Oh, well, I want to show you this. It's really cool, but in order to work, I need to do one more thing. So let me do dashboard, copy. There it. I found it. Okay, so now it's running. Yes, so now I have a new version of the dashboard, which is the one that will be released in the coming weeks, not the one that we have. Okay, so we have this now. I will go to settings, and now I will save this. And I go to syndication, and this is like a test to do everything quicker. Yes, and I'm importing the IPS terminology, which is a very small version of SNOMED with only 9,000 concepts. The normal version has like 400,000. I select these, I add no derivatives, and I say install, because this is using like an alternate distribution system. And it's done. We already, with this, we have the terminology server primed. If I go to the mini browser, all this content was imported by using the dashboard. So this brings me the possibility to have a local terminology server very quickly. Maybe if instead of importing the small one, I will import the complete SNOMED, it will take 10 minutes instead of 2 seconds. But still, it's something that is really easy to do. It's something just point and click. And then when you go to file resources, you can navigate what you have. Yes, and this is what you will present to your users, to your tools, to your systems. So this is the edition you have. You have the international edition, the IPS terminology test. You have no value sets. And you have all these concept maps that are implied by SNOMED CT. Yes, if I click here on the eye and I do like a translate example, well, I don't, this is an implicit map, so it doesn't have explicit codes yet. But this is the ICD-10, the ICD-10 SIM code. Each one of these, it has a map to transform SNOMED into something else. But here in this server, you can add the files that we have exported. So I will use the value set that we translated, and I will add it, okay? And I have the ASMA IPS value set, the one I created with you, with the 14 concepts. The term is not there because on the expansion it will get the term, but it's there. Yes, and if you want to see how do I expand this using Fire, you can click here, and you have an operation. And these kind of operations are the operations that you will do to access the SNOMED. If you want to create a Python script, if you want to connect it to any kind of tool, you will use your local terminology server in that way. And if you go to the concept map, you can choose a file and import the mapping demo that we just created. And you can add the concept map. And now I need to move the things around. And now we see all the implicit concept maps that are the default maps that come with SNOMED CT, but then we have this one, which is a demo that we did last Monday. And if you click here, you can see the T1, the T2, how they are mapped to different things. Swollen ankle mapped to ankle edema. This is something that we did in Snap to SNOMED. And if you see a file example, this is the kind of request that you will do. This is a URL that you run from a Python script, for example, and you use to convert things to the other. For example, this is mapping, what is the code? T1, right? But if I say, let's map T10, we find ankle edema. So this is like a full round trip from authoring maps and value sets. If you go back to the first edition, so we have a SNOMED edition. We have imported all these, selecting the derivatives and selecting the language and everything. We import into a terminology server. And then in the terminology server, we connected new maps and we connected new value sets. And that information, those value sets are available to be used by any tool that you connect to a terminology server. So in the next demos, we will go through different tools that connect to a terminology server, and we will show you how they connect to each other and how this what is happening lately this is why it's a SNOMED trend stock, is that everything is connecting together, right? So let's go quickly over AI. Because you know that AI is everywhere, and everyone is trying to see how AI will affect the use of different tools and different standards. And we have two aspects of AI that we treat differently. Yes. The first aspect is the application of AI to translation. Yes, and this is really important because translations are really big. And usually in the past, creating a full language translation was a multi-year project. SNOMED has, like we say, like almost 400,000 concepts. So a full translation requires 5 years at least, or sometimes even more, of teams of translators, companies providing services, going through SNOMED reviewing and things like that. So we are working more and more on facilitating ways in which the first step of translation can be done with AI. So the new translation studio will have that integrally developed by nature in it. So you will have ways to show examples to the system. The system will perform a first pass. You will need to review and correct the first pass and define some styles. These samples will have a combination of different things, like some medications, some procedures, some clinical findings. So you can provide your input or editorial guidance about how to improve translations in different aspects. And then you can run larger batches, and you can review and provide feedback and run larger batches. So you work on a cycle in which something that took many years before, maybe now will take many months or something like that. It will still be a big project, but not something that looks almost impossible like before. So, and this, we always think that this will be applied with a hybrid workflow with AI as the first pass, human verification and feedback, and then a new cycle with an improved AI. Yes, and there are different options. Roy is also testing, customizing some translation models specifically for SNOMED. So there is the option is to use a general LLM, large language model, to translate, that can provide more context and understand this is useful for that, or a more basic translation, but it's more specialized in medicine, and that is trained on more real world samples of translations from publications and things like that. So there are two paths, and for some languages, maybe one of those strategies is better, and for other languages, maybe the other strategy is better. So we think that these new tools will bring a lot of possibilities to improve the translation cycles. Yes. And the second aspect of implementing AI in SNOMED is automatic coding. Yes, is how much doctors will search and type, or they will just code magically in some way. Yes, and so there are different initiatives that we are testing on that. SNOMED launched like 2 years ago, or maybe last year, beginning of 2020. No, it was in 2024. The entity linking challenge. And the entity linking challenge is an interesting project because it has an agreement with the public database of real free text clinical data. And that database, you need to apply with a lot of restrictions and training to see how you use that data. Data is de-identified, but still there are a lot of restrictions about how to access that data. And in the context of the challenge, different companies will get access to that data, and they will train models to try to identify SNOMED codes in free text. To support that, SNOMED created a process in which real-world doctors explore the nodes and tag the nodes with the diagnosis they find. So there was a lot of effort in showing this set of free text nodes to many doctors and resolving all the discrepancy between the human doctors with many revisions and creating a gold standard that is a really valuable resource for creating AI detection systems. And it was like a competition, yes. And this competition, there were the three first. The winners of the competition were the people with a higher score. There was a way in which each one of the companies can get access to the data, detect entities, and submit the entities. And then this submission was compared to the human detection. And these three companies, Kitty, Snowbird, and Mittel, were the ones that they got the highest scores. And they use different strategies. And this is interesting because there's no single way to do it. But yeah, so these tools are available. These tools, some of them are open source, some are closed, and there is a page with the information of this entity linking challenge where there is a lot of information about to learn more about it. It's really an interesting project, and this kind of things will be probably continued with new competitions. But also in parallel, there are other SNOMED projects that are also open source and that are more freely available that try to use standard models like Anthropic Claude or OpenAI ChatGPT to code SNOMED. So for example, if you go to this one, LLM chains entity extraction, this is a GitHub repository. It's completely free. You can download. You need to have your own key to use it in OpenAI or something like that. And when you provide the key, you can run a Python script that will go through a list of sample texts, and it will try to find the code. And it's a reasoning chain. Yes, it's something that it will try to, when it extract clinical entities first using AI, and then it will use a terminology server to match the entity. And that's the great value. If you ask an old model to say, what's the code for asthma in SNOMED, it will probably invent the code right away because it's just a model that is regurgitating training data. And it's inventing every word and also invents the code. So it's completely unusable. But if you go to a more modern model, or if you have the model set up in a way that the model knows how to use a terminology server, what it will do is, if you're looking for asthma, it will go to a terminology server in the same way that we showed you before, and it will search asthma in the terminology server and choose the right code. And it will be really precise. But when you're processing free text, you need to be more flexible. So what you do is you attempt a first search. With a fuzzy search means that it will not find the exact match. You'll find similar things as well. And from the first page of the search, you will select the best match. And then we'll try to give a rating. The reasoner model would say, okay, this was the original text, and this is the code I found. Give it a rating from 1 to 5. And it's more than 4 or 5, then we are fine and we consider that this was successful. But if it's not, then I need to change the text a bit, because maybe the clinical entity was recorded using words that maybe are not in SNOMED. So you request the model to simplify the text and search again. And if it doesn't find anything, to generalize the text and search again. So these kind of techniques are really interesting. And this allows you to create an actual coder. It works really, really well. Yes. So if you look at the text, this is in Spanish, but we use text from the description of clinical cases in the New England Journal of Medicine. Yes, and there are clinical cases published monthly. So we extracted clinical text from there. It's publicly available. And then we try to code this kind of presentation. And it's really interesting. And this shows how available this information is today. Before, creating this kind of natural language processing tools required 2 PhDs and 2 years. And now you can play around with these things and work. And applying the same logic, Kai is also working in a new tool called SNOScribe. And SNOScribe is a tool that is available here in this repository. You need to install it locally. It's not available to use online, but we have a simulation that we will show you later. But the goal is that SNOScribe is an open source implementation of an entity detection system. Yes, and you can pipe it with some maybe audio, transform to text, and then go into SNOScribe. So it's interesting how these things are going around. And all the commercial companies like Epic, Oracle, or Cerner are providing their own views on this. Yes, how they are thinking about they will implement these intelligent scribes that will simplify the use of their systems. Yes, including coding, filling forms, and things like that. So now we can go to the clinical demonstrators part, and we will see a bit like an example of how these AI things will work, but also some other things that are maybe interesting for you. I saw that you have a cancer synoptic data structure presentation later in the cycle. It will be similar to this. I mean, this is really basic, but you will see probably much more advanced and complex. But these are examples of cancer synoptic reporting with SNOMED. This is an effort that tried to create FHIR questionnaires, structured data capture forms that are tailored for specific types of cancer with collaboration from CAP and ICCR. So if you open one of these forms, what you see is a questionnaire with questions and responses. Yes, you have all these questions. Some are conditional. When you click something, some other questions may appear. So it's a very detailed questionnaire to describe breast cancer with the idea of this is what synoptic reporting is. And the great effort behind this is that in order to represent the questionnaire like this, there are a lot of SNOMED codes. Yes, there are 281 SNOMED codes, some codes that represent the question, some codes that represent the answer. And each one of them was selected and collected by a team of experts to create these questionnaires. These are drafts, things that are experimental, but are interesting things that a team in a hospital can use as a starter set for creating their own forms. So this is an interesting new example that we have. Let me share this in the chat. You will receive the presentation, and you will have all the details in the presentation. But if you want to go in and look around these different examples. And we use these tools. This is the implementation demo site that have many things inside. And we use it for training, to explain the potential of SNOMED-CT, to show how SNOMED-CT looks like, and to support implementers and developers to provide best practices and ideas. So, for example, this is one way in which a clinician could use SNOMED. I'm a pathologist reporting colorectal cancer, and I see a form. And I don't know what's behind the form, but when I select a few options, I can type few things, or this can be existed. This is and something like that. When you type all that, then you show the response, and all the information that you clicked is stored in SNOMED codes. So this is an example of using SNOMED using forms and without actually being aware of the complexity of SNOMED CT, because you just manage to select the right options and everything is recorded in the right way. And for example, for this colorectal cancer form, 200 different SNOMED codes are used, yes. But there are other ways in which SNOMED could be used. So one of them is how you would want to demonstrate how you will explore a repository of SNOMED content. Let's say you are collecting SNOMED data for a long time, and you have a patient database with SNOMED. So we created this demonstration that is like a navigation tool that will get you around your database. It's like something, it's like, we call it descriptive population analysis, but it's really using the power of the SNOMED hierarchy to navigate your own data. So let's say here I have 4,468 patients distributed by this age and gender. This is completely fake information. This is synthesized using algorithms to synthesize information. So if you want to find something, for example, I want to explore, to say, let me see the problems in the gastrointestinal tract. Yes, and you find disorders in the stomach, disorders in the bowel, and each time you click, you have the number of patients inside each one of these boxes. And the box size is related to a number. This is 200 patients with gastric hemorrhage and 48 patients with dysmotility of stomach, for example. And if you scroll down, now with gastrointestinal tract finding, we have 1,300 patients with this gender and age distribution, and these are the patients. So you say, why this is here? This is because it has a gastric lymphoma. Why this is here? Because it has an acute gastric ulcer. Why this is here? Because it has gastroparesis syndrome, yes? And if you want to find a particular thing, you can say, let's look for gastroparesis syndrome, and you have 32 patients with gastroparesis, and no more detail. This is the most detailed concept in the tree. And if you click here, you go back, and then you have a bit more. You have 43 patients with other kinds of gastroparesis and other kinds of gastric motor function disorder. And if you go up, you have functional disorders of the stomach, 58 patients. And you drill up and you navigate through the terminology. So this is an example of descriptive analytics. This is something that implementers can show, like software developers, to design something similar. They can look at the code. This is completely open source. And this is also a way in which we have to show the benefits, yes, because sometimes when you start the adoption of SNOMED, you focus on recording, and it's easy to lose sight of the potential of what you can do with SNOMED, and we use this to show them this is what you will be able to do after some time, after you organize yourself to do it. And this is also integrated into the EHR lab. And the EHR lab is the next demo that we will show you. And this is the more complete one that we have. Yes. And it follows the same paradigm. This is an EHR created for demonstration purposes. Yes. So you have a data button. I will clear all the patients. The information here is stored locally. Local storage means that it's stored in your browser. So if you go in, you see it empty. You create a patient, and your colleague in the next computer next to you, you will still see it empty because the information is not submitted to the system. It's only stored in the web page itself, in your browser. Yes, and of course, the data is also simulated data. So in order to start playing around with this, you can click on generate multiple patients, for example. And you can say, let's create 100 patients. And we created using this resource, the global burden of disease, which is a database that contains which diseases are more common for each age and gender. We created this automatic system that will create patients with codes already. Yeah, so we say let's say over 3 years, let's create a bit more female than male, and 55 female, 45 male, and let's say this is age distribution is okay, and I will have a maximum of 6 diagnoses and a minimum of 2. Yes, and you click generate patients, and this creates 100 patients for you, just like that. Yes, it's a simulation. And the idea is that in a very early stage, where you're trying to understand what I can do with SNOMED CT, you can see it live, and you can play around, you can work. And when you see it live, you get inspired. For example, if you are procuring a system, you can compare the features that you see here that are like the ideal features with the features that you see in a system and something like that. So we can go and open any of these patients. So we click here, open the first patient, and we see this one has anthrax pneumonia, motor vehicle collision with a road sign, mild depression, prostatism, and osteominid, which I really don't know what that means. That's a very particular thing. We base it on the burden of disease. We select like high-level parents. Maybe it says like urologic disorder, and then we randomly select any SNOMED CT subtype. SNOMED CT sometimes has very detailed diagnosis. So this is how an EHR could look like, and this is how our like very early SNOMED users can be inspired to say, okay, I could have something like this, I could develop something like this, or I can do something with my providers, show them and say, why don't you show me information in this way? It's possible using the attributes in SNOMED CT, like the location, the finding site or the procedure site. It's possible to aggregate information based on the anatomic location. So this is doing an example of that. And also it's possible to show the information in different in points in time. So different ways to summarize information. So the first example in EHR Lab about how you interact with SNOMED CT is the problem list. And the problem list is the most basic way to enter information in an EHR. And you can say, for example, I will add a new condition, and you say, let's add the gastroparesis, for example, that we gastroparesis syndrome. And I immediately select it. I can select the date. I can click here and understand, okay, I'm searching a condition. So automatically this field is filtering SNOMED CT content for clinical findings. So when I type there, I will not find a procedure, I will not find a drug name, and I will not find the language or the device. I will only find diagnosis. And that's what's called a terminology binding. This field is prepared to be restricted to something that is relevant in this context. So I do gastroparesis, I save, add a condition, and automatically get the ICD-10 code, for example. And this is, and it knows it happens in the abdomen, and it happens in the abdomen because it's what the finding site says. Yes. So this is how things are aggregated. If I go to a summary and I go to gastroparesis, the arrow is pointing to the abdomen of the patient, along with the prostatism. That should be maybe spelled, I don't know, but it's how it's aggregated at least. And if you want to add a procedure, yes, if I type the same thing, I do gastrop in procedures. The terminology server requires some priming. Sometimes when you use the terminology server has been restarted recently, and you are using it for the first time, and you go into for a new restriction, it takes some time. So I type the same thing in a different field, the procedure, and I get different options. And I click gastropexy. If I click here, I can see that this field, the terminology binding, is restricted to procedures. So if I'm a clinician, I don't need to worry about selecting the wrong thing, because each time I click, everything is filtered specifically for me. And now I have a procedure stored. If I want to add a medication and I do gastro in medication, there must be something that starts with gastro medication. Bisagodil gastro resistant oral tablet. And I can type here. If I click here, I see the terminology binding is related to pharmaceutical products. And only the pharmaceutical product that have a precise active ingredient, which is like a subset of all the pharmaceutical products. And I can say that I ordered this for the gastroparesis syndrome, and this is the right date, and it says it's one tablet every 12 hours, and I add the associated medication. So this tries to show you how SNOMED is used in the real world. Sometimes before having a very clinical UI, we had to search in the browser. And we had other more simplified UIs, like a typical encounter and things like that. But it's like we are growing to show more and more complexity in the where am I here in our demonstrations. Yes. So this is how you use SNOMED to code new things, and it's like a best practice example only. If you want to order things like clinical orders, we use this demonstration that is linked to the login content in SNOMED CT. So for example, if I do glucose, I can search for that. For example, this is leveraging SNOMED attributes that come from login parts and properties to say, okay, I only want to see the glucose itself, not other glucose derivation. And maybe I want to see orders, quantitative orders for that. And I say, okay, I will use this one, and I will order this one and this one. I see a check, I can do a preview of the order. This is what the order looks like, and I see the login codes there. But if I click here, I can change the login codes with SNOMED codes. And this tries to convey how you use SNOMED, you're using a terminology server, and you are ordering everything in the back. I can save the order, for example. And something that I didn't show you is that in the background, we are connected to a terminology server. Yes. So if I do, for example, if I open this, this is the network explorer of Chrome. Every time I try to do something, let's add a procedure, and I do appendectomy, something, or I type too quickly. I click appendectomy. You see all these interactions below. And these interactions are the interactions with the terminology server. This is using the SNOMED browser, the public one, and it's an operation that is looking for, inside the procedure hierarchy, is looking for something that starts with append. And you can see all the options. So everything that you do in this screen is being performed to a terminology server. This is just an interface that you have in your computer that is in the background connecting to a terminology server and performing all these operations for problems, for mapping, for clinical orders. We have an encounter form that you can type and say reason for encounter diagnosis procedure. And also we have this AI demo, and this tries to simulate what a scribe will do. And this doesn't have a real AI model on the background. It's just a simulation. So you can add sample text, yes, like this, and this will automatically run a simulated AI detection. And this is what it should look like, yes? Instead of requesting the doctor to fill a form by hand, you allow the doctor just to type and write free text. Or you record the interactions between the doctor and the patient, and then you extract the summarized text from those interactions and you paste it here. And when you do that, you automatically understand that there are some things in the middle. There are some in purple, there are some conditions, in light blue, some procedures, and in green, some medications. And you have a detection report on the right to say, okay, this is good, but maybe I will not record this one, or you can have some opportunity to see what you have today in the problem list and what you have detected. And you can decide whether it's a good detection or it's not a good detection. And also that encounter form with the reason for encounter with the diagnosis or a procedure is filled automatically for you. You can change maybe for a different one, but AI has tried to automatically assign each one of the things that are mentioned here to one of the fields in the form. So automatically you get the codes, you get the form, you can save everything to the patient, and it's done. Yes, well, now you go to encounters, and you have a past encounter here that was recorded automatically by AI. It says AI assisted clinical data entry session, clinical text, something like that. Yes, and in the same way, you can use some forms. Particular, this is like when you go to structured data capture in one of the later sessions in the course, you will review this again in a way that you can design forms that are really flexible, like the ones we saw for cancer synoptic reporting, that maybe are instruments, scores, or things like that. And you can select options from here, like this. I don't need to go through all of them, maybe. This is a classic depression score, and you can submit the response, and this creates a form recorded for you. Yes, but also if you go to manage questionnaires, you can upload your own questionnaires. Yes, if you have a questionnaire that you create using structured data capture later, you can upload here, and when you upload, you will appear here, uploaded forms. You can use these forms that you create dynamically inside the EHR. So this is a way in which in the EHR you have your use of SNOMED in structured things that are fixed, common to all physicians, how to add a condition, how to record an encounter. This is like the fixed way to use SNOMED CT. And then in the clinical forms, you have a very flexible way in which you can add predefined forms or even custom forms, yes, that you create, and you can do things like that. And everything you store is recorded. Click here, and these are the responses to that. So this tries to show you all that. And you can also do things in other allied health disciplines, like dental, for example. You can define an odontogram. This is an interface that will allow you to detect, to code with SNOMED CT dentistry records. And you say maybe the mesial surface of the tooth has a fractured tooth, and you say. Yes, and this is using SNOMED CT for the location, for the disease, for the face, for the number of teeth, and things like that. And the same for nursing. Nursing, you can say I have a heart rate of 110, it's a tachycardia, and blood pressure of 130, 90, something like that. You say. And this is in the background, there are SNOMED codes to identify that this is heart rate and that this is blood pressure. If you click here, you see, but in this case is LOINC and SNOMED codes for heart rate, for example, or LOINC for blood pressure and LOIC and SNOMED for blood pressure. So everything that you type in the background is coded with SNOMED CT. And when you store this information is stored also using a standard. So the simulated EHR in your browser is recording small documents that are file resources. So each time you save something, this is the document that is stored. Then you see the SNOMED codes inside, and the ICD-10 code, for example, inside the file resource. You have the procedures, you have the medication statements, you have the provenance informing that this was created with an AI assistance, the encounter, the response to the depression questionnaire. Everything is a file document and the laboratory order. And when you do all that, you can also say, okay, let's generate an IPS. And when you do that, you can see this is an international patient summary generated based on the information in this page. So this is really ambitious when you see, and it's obviously they developed all this only to explain SNOMED. Well, today using AI is easier to develop these things. We have many users in clinical reference groups that want to see their ideas working in reality. We have clinicians, specialists, and associations. So this has been really useful to try to crystallize best practices, because the specialists see how this works and they say, okay, actually I will improve this, I will improve this, and there's like an improvement cycle in which these user interfaces or procedures are improved every time to make it better and to provide the best example. And the idea is that maybe when you approach this system, you approach it with maybe learning how to create a problem, or maybe learning how to do clinical orders, or maybe learning how to do dental. And then you see that part and you explore and you can share with your colleagues, you can play around. If you have someone who works in software and developer, you can show the source code and they should be able to help you reproduce this in some way. And maybe the last one that is interesting is trying to explore also how interoperability works in the real world. So the other demo we have in this system, we have also the analytics that I showed you before, but for these 100 patients, yes? So we created gastroparesis, for example. So if I look for gastroparesis, we have one patient. And this patient, if we go down, is a male patient, is Philip Jason, the one that we edited. Yes, if I click here, I see all the diagnoses we created for this patient. So you can navigate a smaller set of patients that you know and familiar. And part of the idea of incorporating this into the EHR is to say, if you're a clinician and you want to you want to improve the way clinicians code, to improve the quality and to be sure that select the right codes, you need to transform them from a passive scribe to someone who actually gets a benefit from the good quality of the data. So if you provide a button like this to a clinician to see his 100 patients, patients he sees often that are assigned to him in some way, not other patients that he doesn't know. There's privacy rules around this. Of course, if you want to carry this into reality, there are a lot of privacy considerations that you need to make. But if I work in a clinic and our patients registered in that clinic and I see all those patients, maybe I can navigate those patients because there's a new medication and I want to call some people, for example, I can go to, there's a new clinical guideline for, let's say, infectious intestinal disease, something like that. And then you want to, okay, this guideline changes a few things. So I want to see how I've been treating this patient to see how much I deviate from the new guideline. And then you see, okay, I have all these patients with this diagnosis. So I can go in, I can open the clinical record, and I can see the history and say, okay, if I had this guideline today, I will make this differently. Yes. And so you can learn from your data, you can explore your data, you have more power. And what will happen is that if you say, but I'm not seeing Michael, I know Michael had this disease before, but I'm not seeing it there. Maybe because you didn't code it right. Maybe because you used a term that was too general, you didn't choose the right code. So in that process, because the clinician is using the data he codes, he gets the opportunity to identify gaps, problems, and improve the quality of coding. Yes. And the last one, the interoperability one, and then we can do some questions, is a simulation of in a fully connected system. It's not like if the patient does a consultation in any part of the world or the country, you will get that information automatically in your system. There will be some kind of exchange operation in the middle. That's what we see today. IPS is exchanged using QR codes or using files or using applications and things like that. So what will happen is that you're working in your system and the patient comes with an IPS, for example, a patient summary. It's called International Patient Summary, but it's being adopted nationally in Canada, in Argentina, in many places. It's being adopted also to exchange between hospitals or between regions and things like that. So what we are exploring with our users, the different techniques to incorporate information and to take advantage of SNOMED use. So there's a process in which you get an IPS, you need to identify which is my patient and say, okay, I don't have this patient, so I need to create a new patient with this name. This name comes in the International Patient Summary document in FHIR. And then you need to go through all of them. And let's say I will add only the menopausal flushing, and I will show you something later. I will click next. I will add one medication. I click next, and I will add the allergy. And I'm populating my clinical record by selecting things. And I click import selected items. And now I have my record of the patient based on that electronic document. So with my supervision, there was a process in which I can get information from the patient and I can enrich my clinical record. Yes. And if I'm doing this for the second time, sorry, let me go back. So I will do the same. Now I get the patient is in my database, 100% match. But let me show you something before. I will add something to the record that will collide a bit with the. So let's do breast cancer. Like for example, locally advanced breast cancer, and I add this as a diagnosis. And then I go back to the interoperability demo. This is the same patient. I click next, and I say, let's add a malignant tumor of breast. And then I can find an overlap. Yes, I can say, okay, because I have all this SNOMED hierarchy, I have something in SNOMED, in my record that is more detailed than the broader concept I'm trying to import. So I have locally advanced breast cancer, and I'm trying to import malignant tumor of breast. So maybe I can click cancel and say, no, I should not add this because it will add noise to my system. And this is something that looks simple, but in reality, it's a challenge because how in a world where everyone can exchange information, how I will maintain my clinical record more or less clean? And this tries to leverage the hierarchies in SNOMED to allow you to identify overlaps, contradictions, and superposition of meaning between different things. So I think we're in time for questions, right, Linda? I can update you which guys are coming around, but we have 10 more minutes, something like that. Yes.
Yes, we do have time for questions, and I have a couple, but I will open the floor to the students first.